So nice to meet you. I'm Thomas and Arthur from Marigold. So Marigold, we are a core team on Tezos. We're working on Tezos protocol, on several tools for the Tezos communities. And we have a big focus on scaling solution and layer 2. And we are here to introduce DEKU. So first I will try to explain what is DEKU and why it matters to have this kind of solution for Tezos ecosystem. And then we will have an epic live coding with Arthur. So first, when we talk about DEKU, sometimes we are talking about two things different. So yes, it's a layer 2 and it has 2 layers. First, we have DEKU parametric, also known as DEKU-P. And it will be the main focus for this talk. It's a framework to build a sidechain for Tezos. And we communicated last week about DEKU-C. So DEKU-C is proof of authority sidechain that run on Tezos. So we are right now we are running an AlphaNet on JakartaNet. So if some people want to experiment what is a sidechain, you can do with DEKU-C. It has tickets as first-class citizens, just like reps. And the node, the authorities, is the core team. So right now it's Marigold, but some node will be run by 3D and Nomadic at some point. Right now we have 5 key TPS on the AlphaNet, but we already have 20 key TPS on our development branch. It also comes with WebAssembly VM. So you had, if you were here yesterday, you had a great introduction to Assam by Hans. So it means also at some point some interoperability between rollups and sidechains. So that's also something cool for Tezos ecosystem. And we are Tezos developer. So yes, DEKU-P is made with OCaml. I will not talk more about DEKU-C right now, but if you want to talk about, we can talk about just after. I will tell you a personal story. 10 years ago, I was working in IT consulting with Microsoft, and it was the hype about cloud computing at this time. And I don't know, Amazon had a strange idea to name it public cloud, and it made a lot of companies afraid of cloud. At this time, I think Microsoft had a good idea to come with the idea of hybrid cloud. So hybrid cloud is, yes, it's marketing. But the idea is, OK, don't be afraid about the cloud. You can set up your cloud software on your own infrastructure. And at some point, you can decide if you deploy a new service in your private cloud or in public cloud. That is hybrid cloud. And it was some kind of nice journey for IT director to accurate their team to cloud. And if you look at cloud 10 years after, most of applications are public cloud. It was just, that's something we miss sometime in blockchain industry. It's change management. How can we do some change management to accurate some team, some corporate that may be afraid of public blockchain? And that's the idea behind the hybrid blockchain I put here. DEKU can also be used, not only, but also be used as a journey to help some corporate to come to blockchains. Why all projects are not blockchain yet? Yeah, we have some trade-offs. It was already discussed yesterday. Mainly the TPS, it's not useful for every application. If you look at NFT, you don't need a high-rate TPS, but yesterday I think Arthur talked about gaming, and if you want to come to a provable game, you need more TPS than we have in layer 1 right now. Block finality, we have 2-second block finality, and it's deterministic in DEKU. And also, if you have high TPS, high usage, you may want to lower the fees more than in a layer 1. And that's not an assumption right now on DEKU. It's up to you to build your fees model, but that's possible. So if you look at private blockchain project or yes, mainly private blockchain project, in general, they use blockchain only for one use case. And some of you are already blockchain developer, you know about smart contract, and it requires some training to understand the life cycle of a smart contract, the fact that a smart contract is immutable. That's something that may be boring if you are just managing one use case. And in some ecosystem, they are talking about blockchain application. So if you think at blockchain application, you don't want to come to the whole smart contract game. And smart contracts are not enough. So we want with DEKU give the opportunity to developer to directly hack their own state machine in their blockchain. Doing that, we don't want to come with a new language. The idea is you hack with your own language. So right now, we have a Go SDK, we have a TypeScript SDK, and sure, we have also OCaml SDK. But it's easy to build a new Python SDK or Java SDK if you want to hack with your own language and interact with the blockchain, which is in OCaml. Since it's permission, upgrades are easy. You have some kind of authority, so if the authority decide to deploy a new node, they can do. You don't need to build such complicated things as the upgrade management we have in Tezos. That's very useful in Tezos because it's permissionless. But when you are permission, it's easy to upgrade your nodes. When I say it's an authority, the authority may decide its model. So if you want at some point build some kind of permission model to join your authority, you can. It's not necessary. I talked a lot at the beginning about private blockchain, but it's not only for private blockchain. You can build a public blockchain with a permission model, and you build your own. So I talked just before about final state machine. Just a reminder about what are final state machines. When I talk about state machine, it's just finite state machine we saw in your slide at some point. So it's just a finite set of states and some transition to go from a state A to a state B. And if you think about it, most of our IT application, most of transactional IT is a state machine. That's the case of AWS Lambda if you are in Web 2, or it's the case of smart contract if you are in Web 3. So when I say DEKU P state machine, it's a finite state machine, and it's unopinionated. So you come with your language, and you come with your pattern. There are several patterns to do state machine. If you want object programming style, you can do it. If you want functional style, you can do it. So what does it mean to develop a DApp with DEKU? So like any DApp, it's just a CQRS pattern. You have your off-chain application. You have the blockchain. So yes, it's simplified. It's not just a ledger. Yes, there is a consensus. There are all the part of the blockchain inside DEKU. And when I talk about the parametric state machine, it means you hack your state machine with your favorite language, let's say with OCaml. You build your state machine inside the DEKU blockchain. We have a CLI to do that. And you deploy your blockchain with your state machine. From that point, there is an API. You can submit a command to the blockchain to include operations that will use your state machine. And you can either build your own indexer to request your chain. For DEKU-C, we are building a prototype of an indexer with TZStat. So soon you will be able to use DEKU indexer. So up to you to use this one or hack your own. And yep, that's it. That's not very different of building decentralized application in other blockchain. So this was a missing piece in Tezos ecosystem, And if we are looking on other ecosystem or projects that need a private blockchain right now, where are they hacking? You have Avalanche Subnet, you have Polygon Edge, you have Hyperledger Fabric. And I think DEKU have a unique position in this area because we have a model where in our AlphaNet we are already above Avalanche Subnet in terms of TPS, and we will be above very centralized model like Hyperledger. Sometimes Hyperledger is critiqued about not being a blockchain because it's not deterministic, and DEKU is deterministic as any blockchain. Important thing regarding other solution also is you are not mandatory to stake to use DEKU. So if you want to push some corporate to go to blockchain areas with the journey of using a private blockchain, it's a problem for them to have to stack on chain like Avalanche or Polygon. And yes, as I said, we are a hybrid. We have a bridge, native bridge between the DEKU protocol and Tezos ecosystem. Tezos. So in Tezos, it's a smart contract, and it's directly communicating with the DEKU protocol. So more fun, hacking time.
Yeah, if it works. So thank you, Thomas. So I'm going to walk you through an example of using DEKU and coding state transition function for DEKU. So I'm not sure it is very easy to read it from the back of the room, so I can only zoom so much, plus there's a delay apparently. Okay, it's not working. So if you want to come forward during the demo, don't hesitate. So first, here I'm in the DEKU repository. So you have plenty of files, you have the source, you have a repository called SDK, which contains the SDK for Go and JavaScript language at the time. Also, I have a wallet that I'm going to use during the demonstration with a private key inside of it. And sorry for the mouth noise. And the first thing I want to do is that I want to start the chain to show you how it runs. So to do this, I have to set up the chain. So I'm going to, we have scripts actually. I'm going to type a lot of commands during the presentation. I don't know if you are familiar with Unix commands in general, but everything can be accessed from our repository. We have a README which tells you how to build the project and so on. So don't hesitate to either ask us after the presentation or to look it up. So what this script does is that it initiates contracts on the Tezos blockchain. On my machine, I have the FlexTesa Tezos platform, which is useful for development, but you don't actually have to have a Tezos node on your computer or on your server to use DEKU. You can use a public net as well. And once so I'm going to use this terminal. Once the 3 validators are initialized, you can actually just run the chain. So you may see a bunch of, oh, sorry, I have to put this away. A bunch of text on the screen. Can you at least see that it does produce blocks? Thank you. So here I have a DEKU chain running with 3 validators and a block time of 2 seconds. You can actually configure this according to your requirements. So time to write some code. I'm going to use TypeScript, and I'm very bad with TypeScript, so please shout me something if I forget a semicolon or whatever. So to use the SDK, we provide a few functions, and the first I'm going to show you is the... thank you. Good example. So to use the SDK, we provide some functions in the SDK that you can call... Sorry?
Respectfully.
Sorry?
Respectfully.
Thank you. Yeah, shout out to Vim users. We provide a few functions that allow you to define just the minimum stuff you need. So I'm going to write a very simple transition function. So what's the syntax again? Is this something like that? Yeah, I think so. So I define a transition function, and in my transition function, I just print something to the console, okay? And then I want to use my SDK with an empty state. We'll get back to it later. And this function. So I have to build my my application first. Oh yeah, sorry. And then this is bad. Whoa. Sorry.
You wrote examples as a French guy.
Okay, thank you. Okay, so the SDK is still 1 month old. We have nothing automatic at the moment. You have to do everything by hand. I'm sorry, we're going to improve that, obviously. Maybe thanks to you. So I have to restart the chain, and first I have to tell it where it should get its VM, the transition function we're actually going to use. So this is the worst of the commands I have to type. And then I can start it again. And by default, all the blocks that the chain produces are empty. I have to actually, so it's starting. You can see that it resumes, or maybe you can't, but it resumes at the state I left it in. So we are at block 60 almost. And by default, nothing happens. So I have to actually use another tool we provide, which is called DEKU CLI, which you can use to create custom transactions. So by default, I have to provide a path towards either a node with an RPC operation or to a local node. So here I just provide it with a, oh yeah, I forgot to show you this, sorry. When I started the chain, when I set the chain up earlier, I actually created this data file with the identity of each validator and so on. So here, this is what I'm using. I'm creating a custom transaction that I'm sending to a node. I'm using my wallet as well, and I have to provide a valid JSON payload. Here, the transition function does not depend on any payload, so I can just use null. Okay, and if I do this, in the next block, I'm going to see that the transition did happen. Okay. So I don't know if I can zoom much more than that, but okay. So a transition happened. We provide a few things that you can use during when you develop your application. For instance, you can see who posted the transaction. If you have a notion of permissions of our users in your private blockchain. So, for instance, I can do this. So I have to build it again. And this time, if I post a transaction, oh, maybe okay. So it does print my my address. Okay. So by default, there's no ledger in this chain. There are no fees. There's absolutely nothing. What we use in the wallet is actually just the private key to sign the transactions. Okay. If you want a ledger, you have to implement it yourself, or we could provide one in the SDK, but it's not done at the moment. And if you want a ledger and smart contracts, all that you would have with a blockchain, with a public blockchain, you should use a public blockchain. The goal is to maintain different states than what you would use normally. So I'm going to show you how to maintain a state inside of DEKU Parametric. So let's say that I'm going to implement a very simple counter application where you have a state which is a number, and you can either increment or decrement it. So by default, everything, I may be wrong about this, but by default, everything in JavaScript is a string, so I'm going to treat everything as a string. So if I get my counter, I have to actually convert it to an int. Oops, sorry. And also, I have to give an initial state to the chain. So here, I'm just going to do this. And as I said, we are not dynamically moving or updating the state. So I have to actually erase all the data, all the blocks, and the states that I had for my chain, and initialize it again. So I just run the setup script again. Oh, and actually my script does nothing. It would be better if I print the counter. OK, so I start the chain again. Ah, faut que je recompile, merci. OK, so this is a bug which sometimes happen on not very powerful machine where the chain does not start properly. So I'm glad you're here to notice it. OK, now it runs. I'm still not using any argument in the transaction to the transaction function, and apparently I messed something up. Oh yeah, I'm using the raw counter here. I'm sorry. No, this is normal. So what's happened? So we did see the problem I have here, but that's the magic of the live events, is that when I post a transaction, I observe none, so I'm not sure why.
In the initial state, you have a number, not a string.
Yeah, but it should work, right? It worked for the repetition, so the rehearsal. Yeah, but does...
When you parse it as if it was a string, this is where the problem may reside.
Let's try it. I'm not sure this is it, but I can't think properly right now. So, actually, I have the solution somewhere. So if I really can't do it, I have to just look it up. So let's start the chain again. Yeah, you're right. Thank you. Ah, bah c'est ça. Ouais. OK. OK. Let's compile first and then start the chain again. I'm sorry.
T'as passé top. Live pressure.
Yeah. OK, so I start the chain again. OK, thank you. So here you can see that the counter is 42. Sorry for the waste of time, which is nice again. I'm just going to show you how to actually modify this state. So we also provide a state function that is just a symmetric of get. And as we define state machines, the easiest pattern you can come up with to maintain this state is to have a function that starts from a state, applies a very small changes to it, a very small change, sorry, and returns a new state. So first I'm going to define an enum that represents the modification I can do to my state. And then to make it easier, I'm just going to define the function that applies a transition to the value contained into the state. So it takes two arguments. First, that it takes the counter, which is a number, and it also takes an action. And my screen is a bit small, but so I have actually three possible cases. If I want to protect my state from being corrupted by a user's operation, I have to take care of this by using the first case is that I want to increment the state. Second case, I want to decrement it. And the default case, if I can't pass the operation or the action here as an actual action, I just want to return my default state. And don't get none as we did before. And in order to inspect the operation that the user has sent, I can do it like this. So my next counter is going to be the result of apply transition to my counter using the operation that the user has sent. Okay. And of course, if I want the chain to remember the states, the state that the user has changed, I have to set it using the set function. So I compile this time again. I restart the chain. Okay, and this time I'm going to use the same command as before, but I'm just changing the end here because I want to provide an increment or decrement operation. So I have to write it as a string because it has to be a valid JSON operation. Okay, so if I do it like this, we're going to see that the chain updates the state and the counter is probably too small. Okay, it's 43. Okay. And I can actually do this a bunch of time. And in the following blocks, all the received operations are going to be applied. Okay. There's a small delay because we have to sign the operation to actually send it and to have it included in the next block. But we can actually do this several times in a row. Each time the transition function is called another time. And I can actually also decrement the state. Okay, so I'm going to stop here for the demo. We would like to thank the organizers of the TezDev conference as well, of course, and the Tezos Foundation as well. Thank you for your attention.
Next slide. So yeah, if you are interested, we can take a coffee or beer after. And thank you. Any question? No?
Okay.
Yeah, it's coming.
Thanks so much. So you are targeting kind of quite some transaction numbers, quite some high transaction numbers. How complex can the state updates be for such high numbers of transactions? Like how do you handle reading and writing from your state, from your storage, at such high transaction numbers? What tricks do you use?
It's arbitrarily complex. If you want to re-implement a ledger and smart contract chain inside of it, you can. Actually, we're going to. It's not done like that yet, but we're going to re-implement the DEKU chain with DEKU Parametric.
Is there any requirement on the data storage side that you have, or how do you envision to store data? Because that's the biggest bottleneck. That's why none of the smart contract chains can actually scale.
Sorry?
The storage is the biggest bottleneck in blockchain. That's the reason why most of the blockchains like Ethereum or all the others that do smart contract interactions are unable to scale beyond a certain amount of transactions.
In DEKU, so DEKU scales with hardware. Mainly, it uses intensively the core. So the more the core you have, the more throughput, and the storage. It's only in memory. So everything happens in memory, and for archive, there will be some kind of archiver or indexer. But it's the storage is your RAM. So if you have good RAM, that's speed.
When you shut it down, like what's going to happen to the 42? Like
Yeah, exactly.
You shut it down, then it's back at 42 again when you start it up?
No. This is two different things. We do serialize the state. Actually, do we? Well, I'm not sure what we do with the state at the moment, but here you can see that we initialize it again each time. The goal is to be as permissive as possible regarding this. So in the end, the users might have to use custom functions or custom code to write the state to the disk, for instance. Okay. We don't by default. Okay. Like as Thomas said, the goal is to be as minimal as possible regarding every aspect of DEKU, and for the state, we don't want to impact performance with a bad choice that we could make regarding serialization, for instance.
Next.
So I'm not sure I understand perfectly what's going on. What is the responsibility? What is the problem that is solved by DEKU, which require, the expertise that you want to put in it? I understand you want it to be as minimal as possible.
Yeah.
But what is inside then?
Inside. Which? Okay. Inside of what? Inside. Sorry, I'm not sure I understand the question. Is the question about why are we rewriting a new chain, or why are we making that minimal requirements or hypothesis about that?
The will for simplicity and minimality to be as general as possible. But then, for instance, when you claim that number of TPS, what does that mean exactly? What is a transaction if the transaction is something?
So here it's benchmarking. So it's a ticket transfer. On DEKU we implemented a ticket ledger, and we benchmark ticket transfer.
Okay, so the numbers that you see here, the 5K, for instance, TPS has been reached during benchmarks on the DEKU chain. So it's a smart contract chain, but it does not run on the same hardware as Tezos at all. So we can do different things. For instance, we heavily use parallelism thanks to OCaml5, and we can actually achieve a higher throughput than Tezos for very good reasons. That we have very lower block time. We do very less stuff than Tezos does. So that's the goal. It's pure performance.
So when we say minimalism, it's about mainly about the state machine, and yes, some serialization problem, but DEKU come with all the protocol things, so there is a consensus and so on and so forth. So regarding, for example, it is also the, it's not here, but if you think at many, so yes, if you go to Hyperledger, for example, you need to understand every piece of a blockchain. And sometimes you want to start without the need to involve all your IT department on what is a consensus, what kind of lot of problems that are well solved in Tezos, but that are very complicated when you build your own blockchain.
Another question. Yesterday, we were presented the other layer 2 solution like Rollup. Is there interoperability between these two solutions, these two layer 2 solutions?
Depends. So if you go to DEKU, it will require a lot of work to have interoperability. In DEKU, since our first-class assets are tickets, we have a shared abstraction, and that's the purpose of, I guess, layer 2 that will be supported by a core team to be able to interoperate, at least from the data point of view. So yes.
Okay, thanks.
Hi, thank you. I'm curious about the state when I write my contract and I'm updating my ledger. The question comes back from where am I storing that memory exactly? How am I actually managing the node without actually providing a node? I'm coming from Ethereum. I'm just trying to understand how you, yeah.
If you're talking about DEKU, you are building your own blockchain, so you have to do the ops work. So you need to define your authority, which authority will run your chain, and manage the operation. If you come to DEKU, Tezos core team will manage the ops stuff for you.
Gotcha. Okay, cool.
If I understand correctly, you can perform transactions. Okay. What are the costs involved?
That's not true.
If I want to perform a transfer, what are the costs? Like,
You mean as fees or?
Yes, the fees.
If so DEKU is some kind of framework. So you are creating your own blockchain. So you decide. So that's your work to decide if there is a fee. In general, if it's a private blockchain, there is no fees. That's run by a company for application purpose. If you are going to build your public services and you have some kind of permission to join your authority, you decide your fees model.
Okay, I'm not sure to understand if there is a link between the layer 1 and what you've built.
Yes, it's a layer 2. There is a smart contract in Tezos. It serves as so we saw it in the demo. There was some hash in the logs. So at some point, the chain serializes its state in the smart contract in Tezos. So we save the root hash of the DEKU chain.
But are you asking about transferring assets from Tezos to DEKU?
No, within DEKU.
Within DEKU?
Inside DEKU, yeah.
Okay, so once again, we have two solutions. We have DEKU, where you do whatever you want. If you want to implement yet another smart contract chain, you can, but that's up to you. But regarding DEKU, we are building a new chain on which we don't have any wallets for at the moment. Okay, so we have basic tooling on the command line, but that's it. But you can actually have the same, probably the same account model than on Tezos. And then you have tickets that you can transfer from one account to the other, or that you can send to smart contracts and so on.
Okay, so what's happening on DEKU? The hash you're talking about is stored on a smart contract on the layer 1?
No.
No?
Yes, oh, yes, yes. So regarding, so this is a bit technical, but the hash that Thomas mentioned and that you maybe saw on the screen at some times is that when we validate a few blocks on the DEKU chain, we want, let's say, observers outside of DEKU to observe that the state is, that the consensus is happening on the sidechain, okay? Because the security of the sidechain is actually dependent on the security of the main chain, Tezos. Okay? So what we do is that we can't post the actual state of DEKU on Tezos because it's too big and we have several blocks that happen in a row on DEKU, sorry, between each block, on Tezos. So we just update what we call a state root hash, and we post this hash on Tezos. Okay? So on Tezos, you actually have a contract which is called the vault, on which you can deposit and withdraw assets when you use DEKU C. And on DEKU C and DEKU P, you have the security hash that is updated by all the validators. And it's part of the consensus that we maintain. Okay.
So at each block, you update the state?
At some point, not each block.
It's, yeah, it's a bit more technical, yeah.
More questions? All right.
Thank you.
With that, round of applause.